Hi, question number 5. The linear transformation T is such that R4 maps onto R4 is represented by the matrix A, where A is equal to all these values inside, as you can see. Find, for the first part, the rank of A, 3 marks. Second part, a basis for the range space of T. And for the third part, a basis for the null space of T. Now then, to find the rank of this matrix, we could do it by finding the determinant of this matrix, but I would rather turn this matrix into the row echelon form. That's the best way anyway. So our goal is to make 6 a 0. So what we can do is multiply this row 4 can become 6 times row 1 minus row 4, and that's going to give you 6 times 1 is 6, 6 minus 6 is 0. Then 6 times 3 is 18, 18 minus 24 is minus 6. Then you got 6 times 5 is 30, 30 minus 21 is 9. 6 times 7 is 42, minus 27, it's going to give you 15. Right, now we do the same for row 3. So row 3, our aim is to make this 0. Okay, so we can say 3 row 1 minus row 3. So 3 times 1 minus 3 is 0. 3 times 3 is 9 minus 13 is minus 4. 3 times 5 is 15 minus 9 is going to give you 6. And 3 times 7 is 21 minus 21 then minus 11 is going to be equal to 10. Right, so make this one 0, 2. So we're going to say row 2 is equal to 2 times row 1. 2 row 1 minus row 2. And let's do that. 2 times 1 is 2 minus 2 is 0. 2 times 3 is 6 minus 8 is going to be minus 2. 2 times 5 is 10 minus 3 is going to be 3. 10 minus 7 rather is going to be 3. 2 times 7 is 14. 14 minus 9 is 5. And from here this first row remains the same. Now we can divide these rows by their factors. So this one can be divided, so row 3 can be divided by 2, and then row 4 can be divided by 3. If we do that, let us see what happens here. We're going to get, this is the same, 1, 3, 5, 7, 0, minus 2, 3, and then 5, and this is going to become so if you divide that, it's going to get minus 2, 3, 5, 0, and minus 2, 3, 5. Now you see where these are heading. Alright, so if you take from here, you add, you subtract, okay, row 4 can become row 3 minus row 4. So 0 minus 0 is 0. Minus 2 minus minus 2 is 0, 3 minus 3 is 0, 5 minus 5 is 0. You can do the same for this one. You can make row 3 into row 2 minus row 3. So 0 minus 0 is 0, minus 2 minus minus 2 is 0, 3 minus 3 is 0, 5 minus 5 is 0. Okay, so then what we're left with is 0, minus 2, 3, 5. And this is the same, 1, 3, 5, and then 7. This is our row echelon form. From here, where are pivot? Alright, let's take a look at our pivots. So the pivots are, you got 1 here, and you got minus 2 here, because underneath is 0, and underneath is 0. So these two columns, they span the same same vectors for these two. So what we're saying is that the rank, but first of all, let's take a look at the rank. What is rank, anyways? So rank of A. What is rank? It is the highest order of the square submatrix. All right, that whose determinant is not equal to 0. Highest order. Okay, will be all, you can say largest order of the square sub matrix whose determinant is not equal to 0. One such matrix can be this. I have a 2 by 2 matrix here. You can take this, or you can take that. It's a 2 by 2 matrix, the highest order is 2, so the rank is 2. Alright, now for the second part we need to find a basis for the range space. Basis for range space. Okay, a basis for the range space, the answer should then be, you have it there, this column and this column, which is these two ones. So I got then 1, 2, 3 and 6. So I got then 1, 2, 3, 6. So this is the first one. Okay, another basis, the basis has got two set of vectors here, 3, 8, 13, 24. So 3, 8, 13 and then 24. And this is a basis for the range space, also known as the column space if you want. We're looking at the columns, 1, 2 columns. Now this is the second part of the question. Now then for the third part, this matrix we found it in its row echelon form was like this. So in order to be able to find the basis for the null space, I'm going to reduce it to the row reduced echelon form. And in doing so, after you perform the operation, you should be able to come up with 2, 0, 19, 29, 0, 2, minus 3, minus 5, and these remain unchanged. And therefore you augment the matrix x1, x2, x3. Basically we're trying to find solutions, okay, in order to reach the null space. Now from here, if you multiply these equations, okay, you should be able to come up with 2x1 is equal to minus 19x3 minus 29x4, and also 2x2 should be then 3x3 plus 5x4. Now basically this is 2x1, and here we've got 2x1, 0x2, and there's no x2 here, 19x3, here we got 19x3, when you sum in the other side becomes minus 19x3, 29x4. Okay, so here we go, 29x4, and you send it on the other side becomes minus. The same applies to this one. 2 times x2 is 2x2, minus 3 times x3 is minus x3, but when you send it on the other side of the equal sign, you should be able to come up with 3x3, and similarly, I mean for this one, minus 5x4. There we go. That should be then plus 5x4. Okay, so I'm doing this now quickly because the video is going to be too long. Alright, that's why I've cut these shorts. Alright, and okay, so then you should be able to come up with 2x1, 2x2, x3, and then x4, and that should give you these vectors, minus 19x4 minus 29x, x3 here, and then minus 29x4, 3x3 plus 5x4, then you've got x3 and then x4. And if you put this in its parametric or parameterized form, you should be able to come up with a vector like this. So I got minus 19, I got 3 for x3, okay, minus 19, then 3, and this one should be 2 because we got 2x1, 2x2, so that should then be 2. If this was 1 and 1, that should have been then 1. So this is 0. Right. Then plus x4 times the vector. So that then should be minus 29 for x4. Okay, 5. x4, nothing here, 0, and then 2. Therefore, a basis for the null space will be this and this. So your basis, let's put the answer here. Okay, basis for the null space. Can you write it here? That's then minus 19, 3, 2, 0, and this one should be then minus 29, 5, 0, 2. So here we go for this question. Now, when I mentioned about these, the row echelon form and the reduced row echelon form, I could have done these step by step for you and reach this, but I didn't do it purposely because this video will be too long for viewing, and therefore I count on your effort, to check it in your textbooks or with your teachers, and even you can follow some video tutorials from YouTube about how to reduce a matrix to its row echelon form, to its final row echelon form. I hope this has been of help. Take care.